First, we start off with a horrifying incident where two delivery drivers were crushed when a crane suddenly fell from above onto their vehicle. Then we move on to an even more devastating disaster, where a massive dam collapse unleashed a wall of sludge that both crushed and tore apart 270 people in its path. Case number 1. Samut Sakhon Province, Thailand. On the morning of January 15, 2026, a construction crew from Italian Thai Development was working above the live traffic lanes of one of Thailand's busiest highways. Because the project required lifting and placing massive concrete bridge segments directly over moving vehicles, the company had installed a large launching gantry to support the work. Workers had just finished placing a new concrete segment and were repositioning the launching gantry for the next lift. The procedure was routine. The gantry moves forward, the front support is placed on the newly installed span, the anchors are set, and the work continues. Crews on this project had performed the sequence hundreds of times. However, that routine process suddenly went wrong when one of the crane's support legs settled unexpectedly and the entire structure shifted. The movement caused the front main support to sink, throwing the launching gantry out of alignment. As the load shifted, the truss, which is the triangular framework designed to stabilize the gantry, began to rotate. Within seconds, the massive precast concrete segment, weighing hundreds of tons, tore free and crashed down onto the Rama II road below. Dashcam video captured the moment the truss and concrete segment fell. The footage, later widely circulated, showed the machine descending in a cloud of dust and debris directly onto moving vehicles. But once the dust settled, a question spread across the country. How does this keep happening? Because beyond the collapse that was caught on camera, this road already had a long and alarming safety record. Between 2019 and early 2025, Thailand's Department of Highways recorded more than 2,500 construction-related accidents on Rama II road alone. Those incidents left 143 people dead and 1,441 injured. The warnings had been mounting for years. In July 2022, a U-turn bridge under construction on this same corridor suddenly collapsed, killing 2 people and injuring 2 more. The contractor on that project was the ITD-VCB Consortium, the same joint venture responsible for the work taking place here. Then in November 2024, less than 2 years before the January 2026 disaster, another accident struck the project when a launching gantry and several concrete segments collapsed during construction. Multiple workers were killed. Each time, officials promised investigations. Each time, safety measures were discussed. Yet construction continued over one of the busiest highways in the country, with massive steel structures suspended directly above live traffic. And eventually, those warnings caught up with reality. On the morning of January 15th, that reality arrived without warning. 2 people driving to work that morning, a pickup driver and a sedan driver, were crushed beneath the falling wreckage. One was later identified as 51-year-old delivery driver Sompong Srisuk, and the other was Sarawut Wechakan, a 45-year-old pickup driver. Soon after, emergency services received the first calls at 9:15 a.m. Rescue teams from Samut Sakhon Emergency Services, local police, and volunteer foundations arrived to find the steel truss still resting on top of the crushed vehicles, making the structure still unstable. Even though it was immediately confirmed that both drivers had been killed, recovering the bodies took hours. After the wreckage was finally cleared, authorities ordered a 60-day closure of the affected section of the road, while engineers prepared to dismantle and rebuild the damaged spans. By May 2025, concern had grown serious enough that Thailand's transport minister personally inspected the project. He announced the work was 82% complete and ordered the installation of a structural health monitoring system for the steel launching gantries. These systems were supposed to use sensors to detect abnormal movement or settlement in the gantry support legs and warn operators before a structural failure occurred. But the new safeguards changed nothing, because 8 months later, another crane collapsed anyway. However, to fully understand what happened on January 15th, you actually have to go back 1 day earlier, because this collapse was just the second deadly collapse in 2 days.
Around 195 people. Dozens have been killed, and many more are injured in hospital. Right now, there's a search operation underway for victims' bodies.
On January 14th, in Sikyo district, a completely different project suffered a catastrophic failure when a crane collapsed onto a moving train. 32 people were killed and 66 were injured. The contractor responsible for that project was also Italian Thai Development. By the morning of January 15th, news of Sikyo was already everywhere. Prime Minister Anurin Charnvirakul had ordered an immediate investigation. The country was shocked and still grieving. However, the construction workers on this road continued their shift as usual. It was urgent for investigators to determine exactly what had caused the collapse. According to some experts, there were 2 probable causes. First, the support leg had been placed on the tiniest, least reinforced part of the segment. Second, a defective hydraulic collar had failed to fully lock the leg onto the jack shaft, meaning the leg was never properly secured. And the monitoring system, the one that had been announced specifically to detect this kind of problem, was either not operational or produced no alert that was acted upon. Real-time monitoring was not in place. Then, the president of the Engineering Institute of Thailand came up with a bold allegation. They claimed that the launch gantry was outdated outdated and old without proper maintenance. This immediately caused outcry. The political response was also quick. On January 16th, the day after the collapse, the Prime Minister of Thailand convened an emergency cabinet meeting. He ordered the Ministry of Transport to terminate ITD's contracts for both the M82 project and the high-speed rail project, and to pursue legal action against the company. This led 14 of ITD's active projects to be suspended for 15 days until safety inspections. However, surprisingly for a company that has been a culprit in many other accidents in Thailand, they accepted responsibility publicly and pledged compensation to the victims' families. This did not shield them from legal action, however, as soon after a criminal investigation into possible negligence causing death was opened by local police. But as of March, no arrests had been made. And Thailand, it seems, has tried to correct its mistakes as the transport minister quickly announced some reforms. The problem is whether those reforms will last longer than the public attention surrounding the disaster. That's another question entirely. Because Thailand has announced safety crackdowns on this road before, after the 2022 collapse, authorities promised stricter oversight. After another round of incidents in 2023, similar commitments were made once again. And following the gantry collapse in November 2024, officials once more pledged tighter safety controls and improved monitoring of construction equipment. Yet each time, once the headlines faded, nothing changed. The same contractors retained their projects. The same dangerously elevated structures continued to be assembled over live traffic, and the road under the construction zone remained open to the public. So in a way, the collapse of January 15th, 2026 was not exactly an accident. An accident implies something unforeseeable. However, in this case, everything was preventable. If the monitoring system that was announced earlier had been deployed, maybe this wouldn't have happened. This collapse showed how dangerous it can be when warning signs pile up and oversight slowly fades into routine. Small problems appear, reports are filed, and warnings are issued, but because nothing catastrophic happens immediately, the risk slowly becomes normalized. However, sometimes the danger isn't hanging above a highway. Sometimes it sits quietly inside an ordinary building, with chemicals stacked in storage, safety rules ignored, and some inspections bypassed. For years, nothing happens, so people pass the building every day without realizing what is stored inside. But just like in the case of the crane collapse, when enough small warnings are ignored for long enough, the results can be catastrophic. The next disaster followed that exact pattern. Case number 2, West Fertilizer Plant Explosion, West Texas, 17th of April 2013. On the evening of April 17th, 2013, a patrol officer noticed the smell of smoke near the city park in West Texas. As he tried to locate where it was coming from, someone directed him toward the West Fertilizer Company building at the north end of town. When the officer arrived, he saw flames rising from the northeast corner of the building, shooting upward through the wooden structure. He immediately radioed dispatch, and within minutes, the local fire department was on its way. But the situation escalated faster than anyone could respond. At approximately 7:51 p.m., less than 22 minutes after the first emergency call, the West Fertilizer Company building exploded.
You got that bring on video. God damn. Holy.
The blast registered 2.1 on the Richter scale. It was equivalent to 7.5 to 10 tons of TNT. The explosion created a crater of 90 feet wide and 10 feet deep where the building had stood, bent railroad tracks more than 2 feet out of alignment, and was felt 65 miles away in Arlington. The building at the center of the explosion had been in town since 1961. It originally started as a grain warehouse, but over time, it was converted into a fertilizer storage and distribution facility by a man named Donald Ray Adair. He was a local businessman who had bought the facility in 2004, and by 2013 started storing ammonium nitrate in wooden plywood bins in the building. And on the evening of the explosion, it was estimated that 40 to 60 tons of ammonium nitrate were being kept inside the building. For those that don't know, ammonium nitrate is the same compound used in ANFO mining explosives. It's the same material Timothy McVeigh used in the Oklahoma City bombing. When this chemical is heated, packed so tightly, and comes into contact with the right organic material, it becomes highly explosive. Now, this fact is not some unknown chemistry. It is documented in every hazmat training manual, every OSHA standard dealing with oxidizers, and every chemical emergency response guide printed in the last 50 years. Yet the West Fire Department had never been informed that the building they might one day respond to contained large quantities of it. When firefighters arrived to deal with the smoke, they brought 2 engines, 2 brush trucks, and a water tender, staging their vehicles east of the building. The problem is, most were not full-time firefighters. They were unpaid volunteers, trained primarily for brush and structure fires. Then, from outside the structure, they began directing water through the northeast doorway where the flames had been seen. During the fire, the assistant fire chief arrived at the fertilizer building and began coordinating with other responders as crews worked to control the blaze. At the time, probably none of the firefighters fully understood the danger posed by fertilizer-grade ammonium nitrate. The material is classified as an oxidizer, not as an explosive. Under normal conditions, it does not detonate on its own, but things inside this building were far from normal. To put into perspective, nearly 60 tons of ammonium nitrate were stored inside a wooden structure that had been burning for roughly 20 minutes. The fire had spread through wooden rafters and plywood storage bins, producing soot and other combustible residues that contaminated the fertilizer. When firefighters then started to open the doors, trying to direct water inside, oxygen rushed into the structure, driving the flames deeper into the storage area. The heated, contaminated, and partially congested ammonium nitrate reached the exact conditions it needed to detonate. What followed was a low-order explosion equivalent to several tons of TNT erupting in the center of a residential town. The blast wave moved outward across 37 blocks. 500 structures were damaged or destroyed. The West Terrace apartment complex, 454 feet from the crater, had collapsed walls with 2 dead residents. West Intermediate School, 552 feet away, lost its roof. The library burned. West Rest Haven Nursing Home, 629 feet away, had some walls blown inward and had to evacuate 145 elderly residents through broken windows while the roof crumpled above them. 12 emergency responders were killed, and 5 were West volunteers. 4 were firefighters from neighboring departments who had been attending an EMT class nearby and came to help when the call came in. The U.S. Chemical Safety Board spent 3 years investigating the disaster. In January 2016, it released its final report. It revealed something troubling. The conditions that led to the explosion had been allowed to exist for decades. OSHA's last inspection of the West Fertilizer facility was in 1985. That was 28 years before the explosion. Then, in 2006, the Environmental Protection Agency fined the company $2,300 for failing to update its required risk management plan. Even the company's own insurers had identified serious safety problems. During a 2008 inspection, they discovered damaged electrical wiring inside the facility. When they returned in 2009, they had not fixed the same electrical wiring. The insurer ultimately recommended that the company's insurance not be renewed because the issues haven't been fixed. While their insurers left them, it would turn out that the company was off the grid. The Department of Homeland Security requires any facility storing more than 400 pounds of ammonium nitrate to file a report. West Fertilizer, however, was storing about 270 tons, roughly 540 times the reporting threshold, and they never filed the required paperwork. As a result, DHS had no facility record. When investigators checked the building, they found that the building had no sprinkler system, no fire detection equipment, and no blast wall separating the ammonium nitrate storage from the rest of the structure. The fertilizer itself was stored in plywood bins, surrounded on all sides by combustible materials. Even more alarming was the facility's location. There were residential homes just 150 feet away from the property line. A nursing home was just 629 feet away, and the intermediate school was only 552 feet away. In other words, the plant wasn't isolated in an industrial zone. It sat directly in the middle of a neighborhood. The worst part is that none of this was hidden. It was well documented in inspection reports, insurance surveys, and EPA files. Regulators received the information and moved on. No agency with authority to act on the combined picture of hazards has ever looked at the full picture. Each agency held a piece of it, but nobody coordinated. However, despite all the irregularities, it would turn out that the company wasn't directly at fault, but someone had intentionally started the fire. Basically, arson. But that finding only raised a deeper question. If someone deliberately started the fire, what was the motive? The answer may lie in the strange circumstances surrounding the facility itself. Despite storing tens of tons of ammonium nitrate, the company carried out only about $1 million in liability insurance, far below the eventual damages that would exceed hundreds of millions of dollars. That fact complicated one of the first possibilities investigators considered: insurance fraud. The authorities immediately placed a $50,000 bounty on anyone who had information about who started the fire. But as of the year 2026, no one has ever been charged, and the investigation remains open. After the explosion, OSHA cited West Fertilizer for 24 serious safety violations and proposed a fine of $118,300. The city of West eventually settled with ammonium nitrate suppliers CF Industries and El Dorado Chemical for $10.44 million, used to rebuild streets, water infrastructure, and a public safety building. Then in 2019, West unveiled the Fallen Heroes Memorial, which was a reflecting pool surrounded by 15 plaques, one for each person killed, standing about 100 yards from where the building stood. Everything that killed those 15 people was in writing before April 17, 2013. Regulatory failures, missing sprinklers, and all. None of it required a deep investigation to discover. All that it required was someone willing to act on what was already known. However, nobody did until there was a 90-foot wide crater. But what happens when you take the same ignored warnings and apply them to a coal mine that is actively holding 3.5 million cubic meters of a mountain in place while workers stand at the bottom of it? Well, that takes us to our next story. Case number 3. The Alxa open pit coal mine collapse. Inner Mongolia, China, 22nd of February 2023. On February 22nd, 2023, workers at the Xinjiang coal industry open pit mine clocked in at 1 p.m. for the afternoon shift. The mine sits at Alxa Left Banner, deep in the Gobi Desert of Inner Mongolia, near the small village of Tumor Bulag. It is remote enough that most of the outside world had never heard of it before that day. The terrain is dry and flat and wide open, the kind of landscape where even a mine the size of several city blocks is dwarfed by what surrounds it. That afternoon, operations appeared completely routine. Haul truck drivers lined up at the loading face, waiting for coal from the excavators cutting into the seam along the pit floor. From inside the pit, looking up at the 315-meter-high wall rising above the loading area, nothing looked any different from any other shift. At 13:12, the southeastern slope of the Xinjiang mine suddenly gave way. A massive wedge of rock and soil, an estimated 35 million cubic meters of material, broke loose from the high wall and began sliding down toward the pit floor. Within seconds, the collapsing mass shattered and surged forward. The debris spread across the mine floor, stretching about 500 meters long and 200 meters wide, and piling up to 80 meters high when it finally slammed into the opposite wall. Haul trucks and excavators were caught directly in its path, while some were overturned and others vanished under the debris entirely. Workers had only seconds to react, and a few managed to radio for help from inside their cabs just before the wave of rock and earth reached them. Workers on the far walls of the pit ran, while those on the pit floor did not make it at all. Then, at 18:44, 5 hours and 32 minutes after the initial collapse, the slope moved again. This time, a secondary failure sent more material sliding down, including some rocks that had already been destabilized by the first collapse. When this happened, some rescue crews had began cutting into the debris and noticing the risks. They waited for the slope to settle, then they returned and resumed the search. What investigators would later discover was that the mine's most basic safety design had not been followed. The southeastern high wall at Xinjiang was supposed to be engineered with 21 individual benches, flat, steep terraces cut into the slope. These benches are designed to interrupt falling material, distribute the weight of the rock, and prevent a single continuous failure from running from the top of the wall all the way to the bottom. In open pit mining, benching is not optional. It is the primary structural system that keeps a high wall from collapsing. But the contractor responsible for converting the site from an underground mine into an open pit operation had not built the full 21 benches. They only built three massive steps, the tallest reaching 145 meters high, leave behind a nearly continuous rock face where a series of staggered terraces should have been. While the contractor was cutting the wall in a configuration it was never designed to hold, the mining company was simultaneously excavating the toe, the base of the slope, which provides the lateral resistance that prevents the wall from sliding outward. Between December 2022 and February 2023, they deepened the pit by 65 meters in an aggressive production push. While they were removing the base, waste rock was being stockpiled at the crest, the top of the slope, adding even more load to a wall already carrying more than its structure could support. They were basically removing the bottom and adding weight to the top at the same time. Deformation at the slope began accelerating at around September 2021, and satellite analysis later showed that the instability had been developing long before the collapse. What made it worse was that the mine had no monitoring system, ground-based radar, or GPS survey points on the slope. They were just eye-testing it. That morning, some of them noticed small rocks and slag falling from the slope, but they mostly thought that was normal. Blasting and excavation dislodged surface material constantly, and there was no evacuation order issued. China's emergency response was extensive and immediate. By the morning of February 23rd, there were over 900 rescue personnel on site. The Ministry of Emergency Management deployed 109 specialist rescuers, while the local authorities sent 238 firefighters, 41 engines, and 6 rescue dogs. 19 teams with over 200 pieces of heavy equipment worked 24-hour rotations in the Gobi Desert. They dug trapezoid-shaped trenches into the debris to maintain slope stability while excavating downward. Then they started deploying ground-penetrating radar and sound detectors. They even involved some rescue dogs. That day, 6 miners were pulled out alive, severely injured. However, the last living worker was recovered the next day, 24 hours after the initial collapse. After that, they just started recovering bodies from debris that was tens of meters thick in places. By June 21st, 2023, rescue operations were officially concluded. 53 were confirmed dead and 6 were injured. 2 months later, in August, China's State Council published its investigation report. It turns out that the contractor, Hongxinyao Earth and Rock Engineering Company, had no valid mining license and had not followed the approved design, producing, in the investigators' words, an extremely high and steep slope. The mining company had continued intensive extraction while construction was ongoing, mining the toe while loading the crest, in direct violation of rules requiring production suspension during major construction. Aside from that, the mine had received received more than 20 warnings and penalties for safety violations before the collapse. In June 2022, 8 months before the disaster, inspectors cited the company for multiple safety violations, including insecure access routes, unsafe storage of flammable materials, and workers operating equipment without proper certification. The company paid the fines, the violations were formally recorded, and the case was closed, but in practice, nothing changed. Investigators later discovered that supervision companies responsible for monitoring compliance had falsified documentation. Reports that should have flagged ongoing safety risks had been altered to show that the mine was meeting required standards, creating the appearance of compliance where none actually existed. Following the collapse, police detained 19 people connected to the mine's operation. Prosecutors ultimately approved arrests for 13 of them on charges of causing a major liability accident. At the administrative level, 42 officials were held accountable through disciplinary action, including suspensions, demotions, and expulsions from the Communist Party. This collapse showed how a disaster can build slowly beneath the surface, with warning signs appearing months or even years before the moment everything finally gives way. But slope instability and mining shortcuts are not the only ways that ignored warning signals can turn routine operations into mass casualty events. Sometimes the danger is not in the ground beneath the worksite, but inside the machinery that powers it. And in August 2009, at one of the largest hydroelectric facilities on Earth, a machine that engineers already knew was unstable was allowed to keep running until the moment it violently tore itself apart. Case number 4. Sayano-Shushenskaya Hydroelectric Power Station Disaster, Khakassia, Russia, 17th of August 2009. On August 17th, 2009, the morning shift at the Sayano-Shushenskaya Hydroelectric Power Station in southern Siberia began the same way it had for 30 years. Around 300 workers were on site. Some were arriving for shift change, while others were midway through scheduled maintenance. Inside the turbine hall, 9 of the plant's 10 massive generators were operating, pushing out roughly 4,100 megawatts of electricity. From that single facility, power flowed across the region, feeding aluminum smelters, industrial plants, and hundreds of thousands of homes. It was the largest hydroelectric facility in Russia, built on the Yenisei River behind a 242-meter arch-gravity dam with a reservoir holding over 31 cubic kilometers of water behind it. The plant had been running since 1978, but under all this normalcy were warning signs that had been building for months. Some of the equipment inside the station had been malfunctioning, particularly Turbine Unit 2, one of the 9 generators running that morning. Its vibration sensors had been showing dangerous readings since at least June. That morning, the amplitude had reached 840 micrometers, but the maximum allowable limit was 160, yet no one did anything about it. However, as with many of these cases, there comes a breaking point. That breaking point came at 8:13 a.m. when the turbine's mounting bolts failed. The head cover, the massive steel plate that seals the top of the turbine against the upward hydraulic force of water pushing through it under pressure, began to lift from its housing, and within a fraction of a second, the remaining bolts holding it in place snapped in sequence. The entire 1,860-ton rotating assembly, the rotor, the shaft, everything connected to it, shot upward and tore through the turbine floor, through the reinforced concrete above it, and through the 27-meter high roof of the turbine hall. The hole left behind became an open drain into the powerhouse, 360,000 kilograms of water per second blasting into a building full of people. The rotor tore through overhead cranes and ventilation ducts as it went up. Metal shards and chunks of concrete were thrown across the hall. Then 2 711 megavolt ampere generators exploded underwater as the flooding reached their electrical systems. The short circuits wiped out power to the entire facility. The turbine hall went dark and began filling with water. Workers described hearing a deafening roar before anything else registered. One technician later said he heard what sounded like a sudden surge, and when he looked up, he saw the turbine cover bulging upward, as if something beneath it was forcing its way out. Seconds later, the explosion hit. Another worker felt the floor physically heave beneath his feet before a piece of flying debris knocked him sideways into the rising water. There was no warning siren, no countdown. One moment the shift was routine. Next, the ceiling had been torn open, and water was pouring into the turbine hall from below. Some operators did not run for the exits. Instead, they ran toward the manual gate controls on the spillway platform, because closing the emergency intake gates was the only way to stop the water from entering the turbine hall. But the gates were never designed to be closed under these conditions. They had to be turned by hand cranks, working against the immense pressure of water from the reservoir above. The resistance was enormous. It took over an hour to fully close the first gate. During that time, the plant continued taking on water. The plant's automatic protection systems should have triggered a remote emergency shutdown. Instead, those systems were disabled almost immediately when the flooding began. Control room operators heard the explosion, watched alarms ignite across every panel, and then gradually lost their instrumentation as electrical short circuits spread through the facility. Within minutes, the control room was effectively blind. Operators had no way to see the state of the turbines, no way to communicate with workers workers trapped inside the turbine hall and no way to activate the remote control systems designed for emergencies. At that point, the only actions left were physical ones, carried out by workers already standing in the water. Damage quickly spread through the turbine hall. As the flooding advanced, turbines 1 and 9 were knocked out, while the remaining units suffered varying degrees of damage as water and debris tore through the machinery. Within roughly 75 minutes of the initial failure, the Sayano-Shushenskaya plant, which had begun the morning producing about 4,100 megawatts of electricity, had fallen completely silent. The human toll was severe. 75 workers were killed and 13 more were injured. Most victims either drowned in the rapidly rising water or were struck by debris during the explosion and collapse. Several bodies were later discovered in maintenance tunnels below the waterline, where workers had been trapped as the flooding spread through the facility. Recovery crews spent weeks combing through the wreckage of the turbine hall. The disaster also triggered a major environmental spill. Between 40 to 100 tons of transformer and lubricating oil flowed into the Yenisei River, forming a slick that spread as far as 100 kilometers downstream, coating riverbanks and killing fish in nearby breeding farms. The government investigation that followed released its findings in October 2009. What it found was a machine that had been sending them warnings for months and a system that had been built to ignore it. The turbine had a documented vibration issue going back years, and as early as 2007, a risk inspection had already warned that the plant's vibration monitoring program was below industry standards and that predictive maintenance practices were not being properly applied. The unit had undergone major overhauls in 2000 and 2005, and in the spring of 2009, engineers installed a brand new turbine runner in an attempt to improve performance. But instead of stabilizing the machine, intervention seemed to worsen the problem. By June 2009, sensors on Unit 2 were already recording vibrations of 600 micrometers, nearly 4 times the safe operating limit of 160. 2 months later, on the morning of August 17th, the reading had climbed to 840 micrometers, more than 5 times the allowable threshold. Engineers had also documented visible cracks around the turbine head cover, a sign that the structural components were already under severe stress. When investigators later examined the wreckage, they found that 49 of the 80 clamping studs that held the turbine in place had developed fatigue cracks after years of repeated mechanical loading. Even more alarming, at least 6 of the 80 fastening nuts were missing entirely. At the same time, the turbine itself was inefficient. To generate about 475 megawatts of power, Unit 2 had to open its water control vanes to 69%. Most turbines producing the same output would only need 40 to 43%. That gap revealed a serious problem. The turbine had become inefficient, forcing far more water pressure through the system than it was designed to handle, and that extra force was pushing directly against the mounting studs that were already cracking under stress. A month before the disaster, a commission from Russ Hydro formally recommended that Unit 2 be taken offline because of its escalating vibration levels. The recommendation, however, was ultimately overruled. Around the same time, a fire at the Bratsk hydroelectric power station had reduced regional power supply, and grid operators were already under pressure to stabilize electricity production across Siberia. Because of this, the regional dispatch center insisted that Unit 2 stay online. The turbine was being used to help stabilize the electrical grid, which meant its power output had to constantly move up and down. Every time the output changed, the turbine had to pass through what engineers called the rough zone, a range where water flow inside the machine causes strong vibrations. This happened several times a day, putting more and more stress on the bolts holding the turbine in place, many of which were already developing cracks. The final investigation by Rostehnadzor reached a blunt conclusion. The accident was preventable. Investigators determined that a chain of avoidable decisions had allowed the turbine to remain in service despite clear warning signs. Finally, on December 24, 2014, more than 5 years after the accident, a court in Sayanogorsk delivered its verdicts. Former plant director Nikolai Navalko and chief engineer Andrei Mitrofanov were each sentenced to 6 years in prison. 2 deputy chief engineers received prison terms ranging from 5 to 6 years, while 2 equipment monitoring specialists were given suspended sentences. 1 defendant was later pardoned. Reconstruction of the plant had already begun almost immediately after the disaster. Operator Roshydro spent about 41 billion rubles rebuilding the station. All 10 turbines were replaced with redesigned units that used stronger materials, improved hydraulic runners, and most importantly, automatic shutdown systems capable of instantly disconnecting a turbine if vibration exceeded safe limits. Real-time digital monitoring was installed and connected directly to automatic shutdown systems, so dangerous vibrations would immediately trigger a turbine trip. By November 12, 2014, the final turbine was installed, restoring the plant to its full 6,400 megawatt capacity. Families of the victims later received compensation from Russ Hydro and the Russian government, though many said that the payments did not reflect the scale of the loss. The cleanup effort also exposed corruption. In 2011, a senior engineer was fined 3.3 million rubles after investigators discovered that he had awarded recovery contracts to to his own company. Today, the rebuilt Sayano-Shushenskaya Dam still operates as a major power station, but it has also become a tourist site. Roshydro opened the facility to visitors in October 2021, and a museum at the dam now includes exhibits recounting the disaster. Case number 5. Tlahuelilpan Pipeline Explosion, Hidalgo, Mexico, 18th of January 2019. On January 18th, 2019, in a field outside the town of San Primitivo, Mexico, a Pemex fuel pipeline had been illegally tapped and was spraying gasoline into the air like a broken fire hydrant. In the weeks before that, Mexico had been dealing with widespread fuel shortages after a government crackdown on pipeline theft disrupted supplies, leaving long lines at gas stations and many communities struggling to find fuel. So when word spread about the leak, hundreds of people arrived with containers, and by the early evening, around 800 people were standing in the field around it. The pipeline was the Tuxpan-Tula Poliducto pipeline. It was a 290-kilometer line that ran on the Gulf of Mexico coast inland to distribution hubs near Mexico City. The pipeline itself was buried underground, but the farmland above it was open and easy to reach. Earlier that afternoon, around 2:30, a group of fuel thieves had drilled into the line, creating an illegal tap, but not long after, about 25 soldiers from Mexico's Secretariat of National Defense, who were patrolling the area as part of the government's anti-fuel theft campaign, discovered the breach. By the time they arrived, however, the thieves had already fled. According to the soldiers, the leak initially appeared small, and due to poor signal, they could not transmit the intel of the leak until almost 5 o'clock. What the soldiers described was a bubbling pool of fuel with nobody present, but less than an hour after they left, things turned for the worse. Under pressure, gasoline was now blasting from the breach at a continuous arc, shooting more than 10 meters into the air. Word had spread so fast that people had driven in from surrounding communities, carrying buckets, plastic jerry cans, and 50-liter barrels loaded into the backs of pickup trucks. Children were standing under the spray, while adults waded through the fuel that was pooling on the ground around them. Then, at approximately 6:52 p.m., something ignited the gasoline vapors that had been silently building across the field. People closest to the fountain were engulfed almost instantly. The flame front swept outward, through the gasoline-soaked ground, catching on clothing, on plastic containers, on the fuel coating every surface. Jerry cans that had been filled minutes earlier exploded. Pickup trucks went up. Those who were not immediately engulfed tried to run, but the ground around them was burning. One woman told Reuters she had grabbed her 17-year-old brother and pulled him away from the fire, and felt the skin come off his body in her hands. By the time the first ambulances arrived, the fire was still burning, as the fire was not fully controlled until nearly midnight. Then, at around 12:45 a.m., President Lopez Obrador arrived at the site.
Tenemos el compromiso de seguir atendiendo las causas, sobre todo la desatención, el abandono a la gente, la desatención, el abandono a los pueblos, a las familias, a los jóvenes.
Initial reports that night said at least 20 dead. However, by the following day, authorities were reporting 85 fatalities, but that number kept climbing as burn victims with injuries across 80% or more of their bodies died in the hospital over the following weeks. Then, the final death toll reached 137 people. Of the 68 bodies recovered at the scene, only 9 were initially identifiable. Most had been so severely burnt that they could not be recognized. In the aftermath, the investigation conducted by Mexico's National Human Rights Commission found out that a formal request to shut down the pipeline did not come until 6:10 p.m., nearly 4 hours after the breach had first been discovered. Then it was not until 6:20 p.m. that the remote valve was closed. However, the shutdown was not instant, because the system required sequential closures at multiple stations to prevent rupturing the line elsewhere. This meant that the fuel was still pumping 4 hours after the pipeline had been shut off. However, that wasn't the worst of it, because what the crowd gathering fuel could not perceive was the vapor accumulating around them. Gasoline vapor is heavier than air, so instead of rising and dispersing, it spreads along the ground and drifting invisibly away from the source while still being a potent explosive. In this field, hundreds of people were walking through fuel-soaked soil, some wearing synthetic clothing that could generate static, while metal containers scraped against the ground. Any of those small sparks could have been enough to trigger the explosion. The CNDH concluded that both Pemex and the military had committed some blunders that directly contributed to the scale of the disaster. Pemex had failed to classify the tap as high risk from the outset, failed to communicate communicated promptly up the chain and failed to initiate pipeline closure for nearly 4 hours after the breach was found. The SCADA monitoring system used on the Tuxpan-Tula pipeline could not be shut down from a single control point. Instead, operators had to manually close valves at several stations along the line, which slowed the shutdown process. Mexico's National Human Rights Commission, the CNDH, later identified this limitation as one factor that contributed to the scale of the disaster. At the same time, the military had no clear protocol for handling large crowds at pipeline leaks. The soldiers on scene were not equipped with protective gear, hoses, or any tools that would allow them to safely deal with the rupture themselves. No individuals were ever criminally charged in connection with the deaths. However, the CNDH's recommendations were absorbed into policy discussions, but how many of them were actually implemented in full remains disputed. However, during the government's crackdown on fuel theft, the numbers initially changed dramatically. Pemex's fuel theft losses fell from 39,388 million pesos in 2018 to 4,645 million pesos in 2019. That was a 90% reduction in a single year, but that did not last because in 2021, losses climbed back to 7,342 million pesos and then to 18,744 million pesos in 2022. By 2023, a new illegal tap was being drilled somewhere on the network every 43 minutes. In the first year of President Sheinbaum's administration, there were 9,520 recorded taps nationwide, and Hidalgo, the same state where this disaster happened, led the country with 2,463. As for the 137 families, there has been very little compensation. Following the disaster, families received about 15,000 pesos, which is roughly $800, and the Interior Ministry promised that a memorial would be built at the site to honor the victims. But 5 years after the tragedy, the building was incomplete. Widows and orphans also said that scholarships and economic assistance programs promised to the victims' children had either not arrived or had been delivered only partially. In the absence of a formal memorial, some families began building a small chapel themselves near the site of the explosion. However, the legal battle over compensation continued. In November 2020, a Mexican court ruled that the victims' families were entitled to more than $1 billion pesos from an insurance policy held by MAPFRA. However, by early 2023, the company had still not paid out the funds. As tragic as this case was, the scale of the next disaster on our list was even larger. It produced such a massive plume of smoke and debris that it formed a dark cloud visible from space over China. Case number 6. Tianjin Chemical Warehouse Explosions, Tianjin, China, 12th of August 2015. At 10:51 in the evening, on August 12, 2015, a fire began inside a shipping container at the arrival yard of Ruihai International Logistics, a hazardous goods handling company inside the port complex at Tianjin, China. At first, the fire did not look like a lot. Surveillance cameras captured it as a bright patch in one corner of the container stack, the kind of thing that looks initially like a problem not too big to handle. But by 10:52, calls were hitting both the municipal emergency line and the fire service simultaneously, and within 4 minutes, the first unit was on the scene.
是在10:50，大概是10:53接到的命令单出的警，然后到现场可能会10分钟左右就会到达现场。
However, when the first arriving commander pulled his unit up to the outer perimeter of Ruihai's yard, they encountered two problems. The internal roadways between the container stacks were blocked, and no engine could get close enough to quench the fire. And when he turned to the Ruihai employees present and asked what chemicals were stored in the area on fire, they told him that they did not know. Apparently, the documentation of what was stored in which container and in which location apparently did not exist in any form accessible to the people standing there in the middle of the night watching it burn. And so the commanders did what incident commanders do when they have no hazardous materials information at a fast-moving container fire. They default to conventional tactics. They tried cooling the exposures, trying to slow the spread while protecting the perimeter. Everything they did was technically correct. It just happened to be the wrong response for the fire they were facing. And unfortunately, it was too late. So at 11:34, the first explosion hit. The scale of the explosion is clearer in another footage.
Whoa! I'm videoing it. What the
I think that might be a gas station or something.
I guess. Whoa! Oh! What the? No! No, baby! No!
The investigation would later estimate that it released energy equivalent to approximately 15 tons of TNT. The force was enough to destroy everything in the immediate vicinity, fling containers hundreds of meters, and kill every person in a substantial radius outright. It also, in the same instant, sent a shockwave and a wall of burning material approximately 20 meters to the northwest, where separate cluster containers held a second round of ammonium nitrate mixed with reactive metals alongside sodium sulfide and sodium methoxide. Under the combined pressure wave and direct heat of the first explosion, the cluster had no time to resist. 31 seconds after the first detonation, the second one went off.
Yeah, we're dangerous. Oh my god.
Oh dear God, are you filming?
Yes, I'm filming.
Wow! Wow! I think we are dead.
Let's go. Let's go down. Let's go. Come on.
Dashcam footage from a vehicle on a road outside the port captured both events. In sequence, a large fireball rising into the night sky, a moment of stunned recognition in the footage itself as the frame shook, and then 30 seconds later, the second explosion. The pressure wave was so powerful that it blew out windows in residential buildings more than a kilometer away, physically hurled people off their feet in the streets, and collapsed walls across a wide radius. Just like the West Fertilizer Plant, the arrival yard of this logistics company also stored ammonium nitrate. The difference was scale. Compared to what was sitting at Ruihai, the stockpile at the West Fertilizer Plant was small by comparison. There were 800 tons of ammonium nitrate, 360 tons of sodium cyanide, and nearly 50 tons of nitrocellulose and related compounds, alongside dozens of other industrial chemicals spread across 72 categories of hazardous materials, totaling nearly 4,840 tons. And that was what was only found just inside the Ruihai part of the yard. The full compound held over 11,000 tons of hazardous goods across 111 separate chemical types. Because of how dangerous a zone like this was, the Chinese safety regulations required them to maintain a minimum separation distance of 1 kilometer from residential buildings and public infrastructure. However, the nearest apartment block was less than 500 meters away. This then begged the question about how they were even allowed to exist in the first place. The company's chairman, Yu Xuewei, and its vice chairman, Dong Xishuan, would later admit in state media that they had used personal connections with government officials to secure the operational approvals that allowed them to be that close to residential buildings. When investigators began examining the origin of the fire, they focused on the materials stored in the section of the warehouse where the blaze first happened. Among them was nitrocellulose, a compound that if improperly stored can become unstable and spontaneously ignite. On that afternoon, the air temperature in Tianjin had reached 36 degrees Celsius, but inside a sealed shipping container sitting in the sun in a crowded container yard, temperatures could rise far higher, potentially exceeding 65 C. That is dangerously close to the temperature at which improperly stored nitrocellulose can begin to self-ignite. The investigation ultimately concluded that some of the nitrocellulose in the arrival area had been improperly packaged, and with the wetting agent gone, the compound dried out through the long heat of the day until at 10:51 in the evening, when it finally crossed the threshold that chemistry had been setting for it for hours. The investigation estimated that the second explosion released energy equivalent to approximately 430 tons of TNT. A mushroom cloud rose several hundred meters above Tianjin Harbor. Seismographs registered the event as a magnitude 2.9 earthquake. In the seconds after the second blast, the port container yard had become a crater. The human cost was devastating in a particular and awful way. The people who made up the majority of the dead were the ones who had driven toward the fire and ran toward the perimeter and stayed in position while the containers burned, because that is what firefighters do. Among the 173 confirmed dead were 104 firefighters, 24 from the People's Armed Police Firefighting Force, 75 from affiliated and port fire services, and 5 whose bodies were most likely vaporized and were listed as missing and later presumed dead. It was the largest loss of firefighters on duty in modern China since 1949, and nearly 800 more people were injured. If the disaster had ended with the explosion itself, leaving roughly 200 people dead and nearly 800 people injured, it still would have been a tragedy of enormous scale, one that the Chinese government might have believed it could contain and manage. But the blast was not the end of the story. In many ways, it was only the beginning. Among the most dangerous things stored at Ruihai was 680 tons of sodium cyanide, and cyanide does not explode. explode. What it does, dispersed by a blast and saturated into the ground by firefighting water and subsequent rain, is contaminate. Within days, crater water at the site was testing cyanide concentrations of 421 milligrams per liter, a level that was extraordinarily toxic to any organism that contacted it. The contamination spread through surface drains, pooled water, and soil. Authorities eventually treated and discharged 766,000 tons of contaminated wastewater in a controlled release through a port outlet into Bohai Bay. Meanwhile, more than 300 tons of sodium cyanide was never fully accounted for. And if you thought the smoke cleared after the explosion, well, you'd be wrong, because for days, a dark cloud was literally hanging over China. NASA satellites tracked the smoke plume drifting over the bay in the days immediately following the explosion. Monitoring wells constructed within 5 kilometers of the blast site were still detecting contamination above acceptable thresholds months later. Arsenic, benzene, phenols, and polycyclic aromatic hydrocarbons showed up in soil samples across the core zone. The environmental remediation effort ran for years, with the direct economic damage placed at nearly 7 billion yuan by investigators, and insurance analysts estimated insured losses between 1.6 and 3.3 billion US dollars. When the government investigation released its findings, it was confirmed what many had suspected. The disaster was man-made. The report said it was caused by illegally stored chemicals, dangerous materials kept together, and a complete failure of the systems meant to regulate the site. Prosecutors ultimately brought charges against 49 people, including company managers, government officials, licensing authorities, and regulatory intermediaries. However, the accountability was not limited to these few rogue actors. The State Council investigation proposed handling actions against 123 responsible persons in total, because the failure had been distributed across the system and not just confined to a single warehouse. Yu Shuiwei, Ruihai's chairman, received a death sentence with a 2-year reprieve and was also convicted for bribery and other offenses tied to illegal operations. In the aftermath, China launched the nationwide safety inspection campaign, where inspectors were required to come from outside the local governments. This quietly acknowledged that local political connections had allowed the facility to operate without proper enforcement. The government also moved to tighten chemical storage regulations. They now require clearer hazard documentation and address the zoning failures that had placed residential buildings within the blast radius of one of the world's busiest hazardous goods yards. But 4 years later, an even deadlier disaster would unfold 11,000 miles away on the other side of the world. Case number 7. Brumadinho Tailings Dam Collapse, Minas Gerais, Brazil, 25th of January 2019. It was a Friday just before lunchtime, and the workers at Vale's Corrego de Feijão iron ore mine in the municipality of Brumadinho in southeastern Brazil was heading to the cafeteria. The company canteen sat in the valley directly below Dam 1, a tailings storage facility that had been rising above that same valley since 1976. It was a large building, and it was nearly full, with about 300 people in it. At 12:28, a fixed surveillance camera captured the first visible deformation in the face of the dam. The top of the dam began to sink, and in less than 10 seconds, the slope gave way completely. About 9.7 million cubic meters of mud, sand, and concrete suddenly broke loose, transforming into a fast-moving river of debris. Within 5 minutes of the first visible crack, the entire mass was surging downstream. The mud had become an extremely dense, fast-moving fluid carrying enormous energy, packed with iron-rich material. It was powerful enough to tear heavy equipment from the ground and drag it for kilometers downstream. It struck the cafeteria, buried the administrative offices, engulfed 3 locomotives and 132 rail wagons, and then continued traveling, following the drainage channels downstream through the valley for 9 kilometers before reaching the Paraopeba River. The landslide covered approximately 2.7 square kilometers, and at some points, the deposit was 18 meters deep. During excavation of the site, the reports were even more horrifying. Of these 603 cases of biological material that forensic teams would eventually process, approximately 86% were body parts rather than intact remains, because the flow does not simply bury what it reaches, but it also tears it apart. Rescuers described operating in what felt like quicksand, where the risk of sinking made movement feel treacherous, and where the scale of the area to be searched made the operation feel at times like looking for something lost in a landscape that no longer resembled any landscape that had ever existed before. The final confirmed toll was 270 people. 2 of the victims were pregnant. Meanwhile, about 2.8 million cubic meters of the dam's mud and slime eventually reached the Paraopeba River after traveling 9 kilometers from the mine. When it entered the river system, it drastically changed the water and the sediment flowing through the valley. Tests taken just 1 week after the disaster found serious contamination at points as far as 464 kilometers downstream. This led the Minas Gerais state government to warn its residents not to use the river water for anything, not for drinking, bathing, or irrigation. This was a major problem because the Paraopeba is part of the water system that supplies the greater Belo Horizonte region, which is home to about 6 million people. And the damage didn't end there. Studies in the years after the collapse had found elevated metal levels and how, after every rainy season, previously deposited tailings were stirred up again and carried even farther downstream. During the investigation, Vale's own internal risk assessment documents dated October 2018, 3 months before the collapse, that classified that area as having a rupture risk twice the maximum threshold considered acceptable under the company's own internal guidelines. The dam that failed had been built using the upstream construction method, which is the cheapest and historically most common approach to building a dam like this. In upstream construction, each new layer of the dam is built directly on top of the mining waste already stored behind it. This makes the dam cheaper to build because it uses the waste itself as part of the foundation. But that waste, also called tailings, was once a watery slurry and not solid ground. When it becomes saturated, it can lose strength very quickly. Now, this dam has been raised 10 times between 1976 and 2013, and the tailings were last added in July 2016. By January 2019, the dam had been inactive for about 2.5 years and was supposed to be on a path toward decommissioning. But even though no new waste was being added, the dam was still holding about 12.7 million cubic meters of tailings, and the water inside the dam had not gone anywhere. The original dam had been built without proper drainage to let the water escape, and later construction added some drainage features, but they were limited. Much of the structure was built with materials that trapped water inside rather than letting it drain out. Measurements from instruments inside the dam showed that the internal water level had barely dropped in the years after the dam stopped receiving waste. In other words, even though the dam was no longer active, it was still holding nearly the same internal water pressure as when it was operating. The tailings themselves made the situation worse because they contained a large amount of iron oxides. The material could stick together and hold a steep slope that looked stable from the outside, but that strength was deceptive. Under the right conditions, with enough water and internal stress, the structure could suddenly lose that strength and collapse without warning. However, the dam was extensively monitored with survey monuments, inclinometers, ground-based radar systems, piezometers, and everything. The instrumentation suite was thorough, and according to some reports, none of it detected any significant deformations or changes in the period before failure. A drone inspection conducted 7 days before the collapse reportedly showed nothing obviously wrong. However, satellite radar data analyzed after the disaster using INSAR technology revealed something investigators didn't notice at the time. In the year before the collapse, the face of the dam had been slowly moving downward, less than 36 millimeters per year. The movement even sped up during the rainy season, with small horizontal shifts appearing in the lower section of the dam. The expert panel acknowledged the movements but concluded they looked like normal settling, not a warning sign of collapse. This shows the dangers of tailings dams like this one. A structure can slowly move toward failure without showing clear warning signs on the instruments monitoring it until the moment it suddenly gives way. Now, Brazilian regulations require tailings dams like this to be regularly certified as safe by independent auditors. These certifications were the official way of confirming that a dam was stable. In 2018, 2 of these stability declarations were issued for the dam by a German inspection company, TÜV Süd, and as of September 2018, just 4 months before the collapse, the dam was officially declared stable. But the certification process itself had already been compromised. Auditors who refused to sign stability reports were replaced by firms willing to approve them. TÜV Süd was even working both as a consultant and the company certifying the dam's safety, essentially advising on problems while also signing off that everything was fine. The disaster triggered one of the largest corporate accountability cases in Brazilian history. In 2020, prosecutors charged Vale executives and TÜV Süd personnel with homicide, environmental crimes, and manipulating safety certifications. Some cases continue, though charges against former Vale CEO Fabio Schwartzman were suspended in 2024 due to evidentiary issues. Meanwhile, legal battles spread across multiple countries. In the United States, regulators accused Vale of misleading investors about the dam's safety, leading to a $55.9 million settlement in 2023. In Brazil, Vale also agreed to a massive civil settlement in 2021 worth 37.7 billion reais, about $7 billion, to fund environmental restoration and compensation for affected communities.